This conference will now be recorded.
Today is a day one. In day one, we're going to discuss about the Python, and then what is Python, and then Python architecture. We're going to discuss. You already know Python is very object-oriented programming language, as well as it supports functional programming, as well as it's very short and crispy. You can write your codings. Everything you can do in the Python. Before going to the Python features, I want to show how we can execute a Python program. What is the background steps happening in the backend while running a Python program? First thing is, initially in the editor, you can use any editor, Sublime editor. You can use PyCharm. You can use any kind of editors. You can write your Python code. Actually, the code will be like a .py file. In that, you will write some piece of Python codes. That file will be like a source file. If you take any languages, Java or C or C++, there will be a one compiler session will be there. The compiler will compile the entire code, will convert into bytecodes. Bytecodes. But in Python, we have a inbuilt compiler. You can't able to see the compiler, how it's compiled, you can't able to see. Whenever you type some code in your IDE, every line will be compiled instantly using Python built-in compiler. Python built-in compiler. I'm going to show an example to you. For that, I'm going to use the IDE called PyCharm Community Edition. In that PyCharm Community Edition, I'm going to create one new project. Click on new project. The interpreter, I'm going to use 3.9 version. Just click on, give the project name over here. I'm going to make Python basic scripts. Python basic scripts. Click on create. And then I'm going to make it as new window. In this, you can see one main.py file. You can rename the file as well. Okay. You can rename the file as well using refactor. I'm going to keep those basic scripts. Basic scripts. First, what I'm going to do, I'm going to print one statement. In the statement, I'm going to type some hello world. Now, the Python having some built-in compiler. Whenever type some code in the IDE, it will be compiled automatically. It will be compiled automatically. You can't be able to see how its compilation happening. Everything happens in memory. Compilation happens everything in the memory. If you want to see how the compilation happens, if a compilation means it will convert your source code into bytecodes. Bytecodes. It will be in terms of machine understandable language. Machine understandable language. Now, in that you can see a box. That box is called Python interpreter. In that Python interpreter, we have your inbuilt compiler. If you take any language, we have a separate command. I can show the command over here. For Java, what we'll use? for compiling. Java C, file name dot Java. Java C, file name dot Java for Java. For running Java program, we'll use Java only file name. No need to provide any extension. You take any language, C or C++, any language, first you have to do the compilation. But in Python, you should not go for any compilation actually. Okay, it is an inbuilt compiler. Okay, it will convert your code into source code into bytecodes. Now I'm going to show how to see the compiled file. Okay, if you go and refer any other tutorials, they won't see this. They won't say these things to you actually. How to see the compiled files. If I use Java, I'm compiling this file name to Java. The output I'll get is file name dot class. Actually, in this class, you can see all the bytecodes. Bytecodes, machine understandable codes you can able to see. But in Python, there is no such compilation activity. If I want to run some program, what I'll do? Python file name, that's file name dot py. File name dot py for running my Python program. There won't be any compilation activity done, but internally will happen. I am hiding the compilation activity to the user. I'm hiding the compilation activity to the, otherwise I can say I'm hiding the compilation activity for the user. Okay, now I'm going to show how the compilation is happening in the backend. I want to get dot pyc file format. Pyc file format is after compilation you get a file called pyc. If I open this file, it contains only bytecodes. Now what I'm doing over here is I type one hello world in the print statement. What I'm going to do, I'm going to open in Explorer. I'm going to get a new folder. Going to keep as compilation. The folder name is compilation. I'm going to cut this py file. Going to place it in compilation directory. Now I'm going to use the command prompt. In the command prompt, I'm going to run a program. How to run a program? Python basics.py file is going to give the hello world, but I want to show how the compilation is happening in the memory in the through interpreter. Okay, for that we have to use a command called Python -m stands for module. -m stands for module, and then you have to provide the one module name is py compile, sorry, pile, and then you have to provide the file name. What is the file name? basics.py. Now you can see in the backend there is an additional folder is created. PyCatch. In the catch, it's a temporary actually. Okay, you can see the pyc file format. Show more options. Just click on properties. What's the file format actually? It's a compiled Python file. Okay, This is how compilation will happen in the backend, but it will be hidden to the users. It will be hidden to the users. If you want to do explicitly compilation, you can do like this. The command will be Python. The module name is module -m stands for module. The module I given is py_compile. I using this module and then I going to give my file name.py. In the backend, I can able to see one folder called PyCatch. That PyCatch, I can able to see the compilation activity. This file format is what file format is? PYC file format. It contains actually bytecodes. Now I'm going to open this file. You might have question. You only say the it contains JSON once, but if you open any editor, actually it won't show zeros and ones. Won't show zeros and ones because that text notepad editor actually can't able to open and give the corresponding file formats. It open in another file format, that's why showing some U and null showing like that. But actually this compiled file contains only bytecodes. This is how the compilation activity will be done in the Python. But if you want to explicitly compile, you can use this commands. But like any other languages, no need to do compilation. Directly you can run your Python program. How you can run a Python program? Directly you can run your Python program. This is how actually compilation happens. Now I'm going to discuss about what is a Python interpreter. What's a Python interpreter will do? All this going to discuss now. Now, yeah, PVM stands for Python Virtual Machine. In the Python Virtual Machine, you can see the four major things. One is compiler, another one is interpreter, third one is memory manager, fourth one is stack. These are the four important topics in the architecture. It connects four important parts. I can say compiler, interpreter, and memory manager, and fourth one is stack. Now, the first thing I'm going to show what is a compiler will do. In compiler, totally three phases will happen. Compiler, whenever you write some code, first it will do the lexical analysis. You might be wondering what is lexical analysis. I'm going to show one by one. Wait a minute. Lexical analysis. Lexical analysis means whenever you write 1,000 lines of code, it's going to split it. Yeah, whenever you write 1,000 lines of code, it's going to split your code line by line and going to remove the trailing and leading white spaces from your source code. And then it's going to segregate line by line. That's what the lexical analysis will do. This is the first thing in compiler. The second thing is syntax analysis. The lexical analysis output is given to the another module called syntax analysis. In syntax analysis, the compiler verify it's a right syntax or not. If you are using wrong syntax, it will throw compile time error. The lexical analysis output is given to the syntax analysis. The lexical analysis what will do? It will convert. It will take the entire source code and split into line by line, and then that line by line output is given to the syntax analysis. That syntax analysis will check for the correct syntax is present or not as per the Python library. If the syntax is wrong, it will throw compile time error in your PyCharm IDE. The third phase is semantic analysis. Semantic analysis in the sense, for example, I open on document over here for semantic analysis. The semantic analysis, you can go for three kinds of checking. One is type checking, label checking, and flow control check. Before going to that, I will say what is semantic analysis. Semantic analysis is the third phase of compiler. First one is lexical analysis. Second one is syntax analysis. Third one is semantic analysis. Second, syntax analysis. Third one is semantic analysis. Semantic analysis, it will make sure that declarations, what are declarations you mentioned in the program is correct. The statements are semantically correct. It will check. If the statements are semantically correct, then only it will generate the bytecode. If the three phases are not passed, it's not going to generate any bytecode. It's not going to generate any bytecodes. The first phase is lexical analysis. Lexical analysis is going to split your entire programs into line by line, as well as after converting line by line, it's going to split into tokens. Tokens in the sense I'm going to show. Now I'm going to write the program. What the lexical analysis will do. Wait a minute. I'm writing on some for loop over here. I'm writing on for loop over here. Totally I written 4 lines of code, right? Print statement, lexical analysis, one comment block, as well as third is our for loop, and fifth one is print statement. What the lexical analysis will do, it will read the all lines of code and then split into line by line. Split into line by line, and then after splitting line by line, it will split into tokens. Do you know what is tokens? For is one token, I is one tokens, in is one token, range is one token, print is one token. It will split into various tokens. That output is given to syntax analysis, and then Python will check for syntax. This for loop is correct or not, this in is correct or not. Check the syntax analysis. If the syntax is correct, and then the third phase will come for the semantic analysis. Semantic analysis, third phase of compiler. It will make sure the declaration of statement as well as the program is semantically correct. Now I'm going to talk about 2 more things. One is type checking. Type checking. Type checking is nothing but I'm ensuring that my data types are used in a convenient way. I'm going to give an example for you. I'm declaring one float variable. Float x equal to 10.1. Now I'm multiplying 10.1 into 30. This 30 is actually what value? It's a int. If I multiplying int with float, automatically you should convert into float value. This kind of type checking will be done by the semantic analysis. Sangeeta, I think your the float value is float x equal to 10.1.
Okay.
Now I'm multiplying the int value. Int value is 30. If I'm multiplying int with float, make it mute. If I'm multiplying int with float, again it should convert into float value. It's kind of type checking. I want to convert into float value again. Okay, this kind of type checking will be done by the semantic analysis. Second thing is label checking. Label checking means I'm going to assign some variable. See here, value equal to 10. Labeling is correct or not, because I'm giving assign 10 to the value. Okay, this kind of label checking will be done by the. Third thing is flow control check. Flow control check is nothing but I'm using for loops, if loop, while loop, and do while loop I'm using. This flow control check, I'm using one while loop. In the while loop, I have to use break statement. Whether I'm using the break statement inside the while loop or outside the while loop, it will check. If I use the break statement outside the while loop, it's not going to affect anything. It's not going to affect anything. Okay, the flow control check will ensure that the break statement is in while loop or not. That's what it's going to ensure. Like all kind of loops, it's going to ensure the proper control check is happening or not. This kind of things will be happening in the semantic analysis. Totally in compiler we have three phases of designs. One is three phases. One is lexical analysis. It's going to split into various tokens. Second is syntax analysis. It's going to ensure that syntax is correct or not as per the Python library. Third thing is semantic analysis. In this semantic analysis, we have three types. One is type checking. Second one is label checking. Third one is flow control check. We're going to ensure our data types are used in a consistent way. If I'm multiplying some int value with float, again it has to convert into float value, right? This kind of type checkings, and then whenever you're assigning some variables, we are assigning proper labels or not, and then the flow control check is whether you're using the break statement inside the while loop or outside the while loop. This kind of checks will be done in the semantic analysis. If the three phases has passed, then only generate PYC file. PYC file means Python compile file. In that file contains only the bytecodes. Now, I'm going to show one diagram to you. From this diagram, you can able to understand. I'm going to maximize my screen. You can see over here. First, I'm writing in the block. You can see the file name is basics.py file. Basics.py file. In that, I'm writing one function. That function is going to do only one thing. It's going to print only hello world. Print only hello world. Next, the input is given to the compiler. The compiler is having three phases. I already said to you: lexical, lexical, syntax analysis, and then third one is semantic analysis. All these three phases will happen in like a tree format, abstract tree format. Tree means once lexical analysis completed, the output is given to the syntax analysis. Syntax analysis given to output is given to semantic analysis. Finally, once the three phases completed, it will generate a bytecode. It will be generate a bytecode. Now, the bytecode will look like a, hold a minute, the bytecode will look like a assembly language. Assembly language. You might have a question. Now only said like ones and zeros. Now it's like assembly language saying like that, because machines will understand only ones and zeros. We want to convert this bytecode into ones and zeros. Okay. Actually, this bytecode contains only assembly language. You can see, right? Call function, pop. Pop means removing the item. Print. These kind of languages in like a assembly language. Okay. Once you opened this file in your editor, it will show like this, because your editor has not proper encoding format. It won't be able to read this assembly language. Actually, it won't be able to read this assembly language. It won't be able to read the assembly language. It has not having the proper format to read this file format. That's why it's showing somewhat like encrypted, and then you might have a question like then how the machine will understand this language, like call function, pop, print items, how this assembly language understand machine won't understand this language. Now the interpreter will convert this bytecodes into ones and zeros. The processor, what the processor is using, that will understand only the ones as well as zeros. Actually, the PYC file will look like a assembly language, like call function. If you are working microprocessor, microcontroller, they will write on assembly language. Okay, that will understand machines. The interpreter converts into zeros and ones. Now, we're going to discuss. Second thing is interpreter. As of now, you see compiler. Second thing is we're going to see about the interpreter. Interpreter, what we're going to do? For example, if I want to create a object in the memory, directly interpreter cannot able to do. Through the memory manager, it can able to create your object. You might have a question, what is an object actually? In this world, everything is object. Now, I'm going to give some example for you. What is an object? Going to take one new notepad. Going to take one object as dog. Not object actually, it's a class. The class is dog. For a dog, what are properties will be there? What are properties will be there? Color equal to, these are properties, black. And then what are properties? Color equal black. And then legs equal to 4. And then color, legs, what you can say? Tail,
Eyes blue.
eyes equal to. These are the properties. These are the properties. These are the properties. What are the actions will be there? Actions means
Bark.
barking, tagging, dumping, all this kind of actions will be there. All this kind of actions will be there. I will say action, another name is methods. In Python will say functions. Properties I can say variables. Now I have one class. Class is dog. Oh wait, hold a minute. Oh, okay, sorry, I made a mistake. Class is dog, mean that the dog is having various properties as well as various actions. If you take any class, take table. What are properties? Color equal to brown, and then legs equal to 4, and then in a table what you can do? Reading, writing. If in the world, if you take any class like dog, table, chairs, furnitures, anything like a human being, what they will do? Eating, all are called actions. And then black equal color equal to black, eyes equal to 2. These all are called up. If you take any classes, it will have properties and actions. In Python, we will say variables as well as actions. We will say as functions. Now, these are, if you take any things, human being or dog or for tables or furnitures, anything, everything in terms of variable properties as well as actions will be there. Now, if I want to create object for this corresponding class, what I can do? Some variable name. Variable name equal to dog. This is how I can create the object for this class dog. We are some variable, some you can give any name. You can give any name equal to dog. So actually, I can create a object. You might be wondering, like after creating object, what will happen? If we want to assign a memory for the particular object. If I want to call this variable, what I can do? Value dot color. I'll give the color as black because I create an object. Object means I want to create a memory for this corresponding class. For this corresponding class, if I create memory, for the corresponding class, if I create some memory, I can able to access my data members. Value dot color, I can get the value, and then value dot tail, I get the value is 1. Value dot eyes, I can get the value is 2. If I want to call some functions, what can I do? Value dot barking. How will write a method in Python? You have to use define keywords. Okay, like this, you have to call the methods. if I want to access those properties or actions, I want to create a memory for the corresponding class. For that's the reason I using memory manager. The memory manager will allocate a memory for the corresponding class. The class can be a dog class or can be a furniture or table. Any kind of in the real world, everything is object. I'm saying the real world. If you take anything, it's object actually. It is having some properties. It is having some actions. Through interpret what they will do directly won't create a object for corresponding class. Through memory manager, it's going to create an object for the corresponding class. Now you might be wondering like when it create a memory for the corresponding class. During runtime, when you run the program, if I am running this program at runtime only, it will create a memory for the corresponding class. Without memory manager, you can't able to create a object memory. You might be asked a question like, what kind of memory it is? It is a heap memory. The Python interpreter, see in the Python and the PVM stands for Python virtual machine. In the virtual machine only you can able to see the interpreter. Okay. The interpreter used to create an object for the corresponding class through memory manager. And then it has two kinds of memories. One is heap memory, another one is stack memory. If you want to create an object for a corresponding class, you want to heap memory. If you want to store the reference, I want to store the reference of the particular object. For this class, dog class, I created an object. The reference is value. Reference is value. This reference will be stored in the stack execution. In the stack execution. Don't assume like it won't store the value. For every reference, it will have some memory address. See, like 1, 2, 3. For this dog class, it's a memory address. This memory address reference will be stored in stack memory. Stack memory. This is the memory address. If I want to, Sangeeta, if I want to come to home, first we want to get the address. Then only I know where you are located, which place you are located. Like this, for this dog class, this is the memory address. This memory address stored in stack memory. It will be stored in the linear fashion. Okay, it will be stored in the linear fashion, and then the permanent storage will be in the heap memory. Permanent storage will be in the heap memory. The reference will be stored in over here. You might have a question like, what's the interpreter still doing? It's only for creating object, or how it be? Now I have one more diagram for this. Hold a minute. Yeah, actually this is a diagram. This is a high level diagram. Actually, I am writing the source code. After that, the Python is having inbuilt compiler. It's converted into PYC file, compiled file,
Okay.
and then it contains assembly languages. That interpreter, what is doing? It's converting the assembly language into ones and zeros. Then only your computer can able to understand that language, and then it understand able the ones and zeros. It can able to start working on this. What are the code written right? As per the code will work. This is a actually high level diagram. For a simpler view, I can say the interpreter converts bytecode into machine code. This is a thing you can understand. This is what the interpreter is actually doing. It converts the bytecode assembly language into assembly language means bytecodes. Bytecode contains full assembly language into machine code. Machine code means ones and zeros. Okay. Now we're going to discuss about the memory manager. We're going to discuss about the memory manager. Memory manager I already said to you, during the runtime only, it will allocate the object, as well as once execution is completed, it will deallocate the memory. It will deallocate the memory. For example, I can say to you, I have one dog class. For this class, I created an object. The memory assigned for it is 4 KB during runtime. After the code is completed, what it has to do? First, it has to allocate the memory. After the code is completed, after the execution completed, it has to deallocate the memory. This is how Python will handle. Python will take care of this allocation deallocation internally. And then one more important thing you have to remember: whenever you type the code in the PyCharm IDE, the line by line, instantly the line by line will send to the compiler. The line by line will send to the compiler. This is how compilation happens. Now, I already discussed the memory manager. It is going to create the object, as well as this memory manager is going to have a link for this various object, and the object reference will be stored in the stack. It will store the memory address will be stored. Now, next thing is I'm going to talk about this stack execution. Stack execution. Okay, fine. In the stack execution, it will store the memory address in the linear fashion. Whichever object created first, it's going to store in a stack of files. Once the execution is completed, it's going to use a pop function, going to remove from the stack. After that, second program is going to run, third program is going to run. After the program is run successfully, going to remove from the stack. Now we're going to see in depth in the stack what is happening. In the stack, we have two things. One is value stack, another one is block stack. Before going to the value stack and block stack, we'll call the entire stack as one mainframe. In that mainframe, various frames will be available. Frame 1, frame 2, frame 3, frame 4, frame 5, frame 6, frame 7. You can there are a number of frames will be available. You might be wondering why this much frames are available. Because for the same class, I'm going to create different objects. See, value 1 equal to dog. Sorry, value 1 equal to dog. Value 2 equal to dog. See, though it's the same class, but this memory address is different. This memory address is different. This memory address is different. If you want to run your program through interpreter, it needs memory. Without memory, you can't execute a program. I'm creating 3 different objects. You can see value reference is different. Value 1, value 2. It contains 4 KB memory. It also contains 4 KB. It also contains 4 KB. But it has having different memory locations. Reference also different. I can show like this. I like a alphanumeric 1, 2, 3, X, T, F, G. Its address. For this value 1, different address will be there. 23, F, or 4, different address will be there. Value some different address will be there. Now I created 3 different objects. Each object is a frame 1. Another object is frame 2. Another object is frame 3. Like this, you can keep n number of objects, as well as the stack memory. Once the stack memory is exceeded, it will throw one error called stack overflow error. Stack overflow error will throw. It is having only less memory. When compared to heap, it contains only less memory. If the stack is full, it will throw Stack Overflow error. Okay, and then in now we're going to discuss about the frame one. In the frame one, you can see the value stack as well as block stack. Once you create an object, that reference will be stored in the block stack. Once you get the object, this reference is there, right? Reference 23 RF. That reference will be stored in the block stack. And then you might have a question, what's the use of value stack? What's the use of value stack? Wait a minute. Yeah. They have given here, right? Value stack. Yeah. Value stack will hold the values actually. For example, if I declaring some values, value equal 10, value 20, these kind of variable declarations will be stored in the value stack. Value equal 20, value 20, 30, 30, 40, 50, like that, you're mentioning some variables, right? Will be stored in the value stack. Only the object reference will be stored in the block stack. Now, what the interpreter will do? The interpreter will read the code from the compile file as a bytecode. It will convert into ones and zeros. After that, your program will start executing and then it will print the results in the console. This entire block will be like PVM, Python Virtual Machine. Now, I'm going to discuss few of things. Whenever you start a Python program, if you want to check all the keywords, what are the keywords available in Python? First, create your file. I'm going to keep sample scripts. Create a py file. First module I'm going to use as keyword, because I'm going to see what are the keywords available in Python. For that, one module called keyword. Now print. I want to know what are the keywords available in Python. Just call the module. Is actually module dot variable call keyword list. You can see V, right? V means variables, F means functions. I want to know all the keywords list. Just run this program. It will show all the Python keywords: false, none, true, peg parser, and, as, assert, asynchronous, wait, break, class, continue, def. Def means define, delete, else if means elif, else, except, finally, for, from, global, if, import, lambda. These are the Python keywords. If I want to check all these keywords, you can use this module and then you can print the Python keywords. You might have a question, what is a module? Now I am going to discuss what is a module actually. Python module is nothing but a file. It's a Python file. In the Python file, what are things available? It can have classes, it can have variables, it can have functions, it can have constructors. That entire file contains variables, methods, variables, functions, classes. It all the things I can say it's a module. Basically, layman terms I can say Python module is a file. It contains all the Python definitions, statements, constructors, classes, variables, functions. Okay. In that module, it can also contain some runnable code also. Can also have some runnable code also should be there. It can be neither. Runnable code also should be there. Don't get confused. If you don't say our Python module, just think like that. Python module is like a file. It contains variables, functions, as well as constructors, classes, and then it can also contain some runnable code also. Okay, that is called Python module. You might have question like, what is keyword? It's the inbuilt Python module. Okay, I'm going to call this module and then I'm going to access keyword list and get all the keywords. Sangeeta, can I want to compile this code or not? No need to compile.
Yes,
Internally, it will
it
compile.
happens.
It will happen internally. If you want to explicitly compile, you can use this module and then you can see your PYC file. Using the module called py compile, you can use, and then you can externally you can see the PYC file. This is the actual file. See, this is not having a proper encoding format. That's why it's not showing any assembly language. That's why it's not showing assembly language. It's showing somewhat in an encoded format. The assembly language, it looks like this. You can see. You can see, right? Bytecode, call function, pop. These are assembly languages. If you are working microprocessor, then you know about the assembly languages. Fine. Now, what I going to do? I going to say some few things to you. First, I going to create one py file. Simply, I'm going to keep one.py file. One.py file. Now, print. I'm going to print some statement. I want to say what are the modules available. What are the modules available? If you run the program, which module is going to run? Modules. I'm going to show the modules. Now, I'm going to print. I'm going to print what is the module currently I'm running. That's the thing I want to show to you now. Okay, in print statement, I'm going to use double quotes. What's file name actually? File one name is set to see. If I use butterfly, Python is, I have to say it's a placeholders. Placeholders. I am going to use format because I want to print this value. File one name is set to which model I'm currently running. That thing I want to know. For that, I'm going to use name. What is the name of a module? I can mention like this. What is the name of my module if I run this program? Now I'm going to run this thing. See, these are called the placeholders. If I use butterfly brackets as the placeholders, what I'm going to do, I'm going to do the string formatting actually. String formatting means in the string, instead of placeholders, I'm going to place a name here. What are name I'm getting, right? Module name. That name will be set in the placeholders. Will be set in this placeholder. Now I'm going to run this program. You going to say what is the module name? What is the module name? You can see the console. What is the module name? Main module. Main module. You can see the file one name is set to main module. Okay, that thing you want to understand. The module I'm currently running is main module. That's why in Python 2.0 version, you use like this. Your Python virtual machine set one variable called name. Actually, it's a variable name. The Python interpreter will set your variable name. Variable name is name equal to. I'm going to do the equal check. Equal check means you have to use double equal to. Single equal means assigning. I'm going to equality. Equal means I'm going to compare. What am I going to do? If my variable name is main, then I'm going to run my program. Actually, for my interpreter, this is the execution point. This will be the execution point. If I give name equal to main, that's going to execution point. Now, what's my name actually? Main. If this main equal to main, then my execution will run. Print. I'm going to do print hello world. I'm going to run this program. How it's running? First I'm getting the module name as main. If main equal to main, then it's printing the hello world. Hello world. This Python interpreter will set this name because I am running this module. Okay, this module name is main. That's why getting the instead of name and getting main equal to main, both are gets compared. Bool value is true. Bool value is true. It's printing the hello world. This is going to the exit point for Python 2.0. In Python 3.0, no need of if name equal to main. Wherever you can run, anywhere you can run. See, without can run anywhere. See, it's running right. Now, what I going to do? I going to create one more file, 2.py. 2.py. Sorry, I can go and remove that. What I going to do? Copy this thing. I going to change the print statement alone. Print statement alone. Now, if I run this program, what output I'll get? What is my name of a module? What is my name of my module? Same main. Same main module. If I run here also, it's going to be main. Okay. Okay. Now, what I'm going to do in 1.py file, I'm going to import my another module called 2. I already said to you, module is a file. It contains class, variables, methods and functions, constructors. Now I importing my second module in the first module, main module. Sorry, 2.py is a module. I'm going to import in my 1.py file. If I run this program, what will be my output? Because I importing the modulus 2. What will happen? What will happen? Let's see. File 2 name. What's the module name now?
2.
2. See, whichever module you are referring, that Python file name will be your module name. Whichever module you are referring in your main script, that will be your module name, and then this print statement actually running, right? This name will be my main module. Don't get confused. See here, I am removing this module name. It's going to be the main module. Go to 2.py file, run this program, main module. What I going to do? I going to call this module import of 2. Now, if I call this 2 module in my current script, what will happen? It's going to call this print statement. The module I am referring, it won't give the main. Actually, going to give 2 as a module name for this name, and then it will come to this statement. Because I'm running here only, right? It's going to give file name 1 is set to. The format of name is going to give us main. That going to the placeholder. Now you can see your program. If you have any doubts, I can help you out. I'm going to get one more script as well. T.py. Now I'm going to copy the script. I'm going to change some print statement a little bit. Okay. If I run this model, what will output? If I run this model, what will the output? File 3 name is set to, in the placeholder, what value I can get. I'm asking you.
2.
How you can get 2? I have not imported any other module. Directly I'm running 3.py file. I'll get the main module. You can see. Now I'm going to run the 2.py file. What module will get? See, this is my main program I'm going to run. See, this is my main program I'm going to run. I'm going to get again main module. Now I'm going to call my
Import
2 module is import statement. What thing I'll get? Just go to 2.py file. File 2 is set to. The thing I'll get 2, and then it will print like file is set to again main module. You can see, right? File 2 is set to 2, module name is 2. File 1 is set to main module, and then it's coming to the entry point. You checking condition. If my name, what is my name? Main, right? Main equal to main means it's going to print the hello world. Now I'm going to confuse you. What output I'll get? How many outputs I'll get? What are the module names I'll get actually?
Two and 3.
Hello, 2. You will get the 2. Okay, file 2 is set to 2, and then I use import 3 statement. It go to 3, and then file 3 is set to 3, and then finally it's going to print file 1 name is set to main. Totally, I'll get 4 outputs, 3, and then finally print the hello world. I'm going to get the 4 outputs actually. Fine. 2 module is 3,
2, 3.
and then main module. Because from this 1.py file running the script, that's why I'm getting for the liner 5 getting main. If I run here, I'll get the module name as main module. This is main module actually. If I run the 2.py, this may actually be main module. If I import any of statements in my current module, that file name will be given as the module name. Module means files. Files contains class, variables, methods, other things, functions, constructors, anything can happen. Now I'm going to confuse a little bit. Again, I'm going to write some methods now. If make it mute, function one, sorry, function one. I'm going to use hello world, hello world, hello world. I'm going to write a one more function as well. Function two, welcome. Sorry, okay, fine. Function two. Now I'm going to copy these two things, two functions. Def means define, okay. And then I'm going to use, yeah, I'm going to use the function name is p. The function name is for. I'm going to make some modifications. If I want to do some modification, if I want to add, if I want to make changes in my string, I want to use format. If you want to make changes in my string, you can use format, you can use. Otherwise, you can make it as underscore one, welcome underscore one. You can reformat the file. Okay, fine. Just save it. Now, I'm going to remove this import statement. Now, I already said to you in Python 2.0, the interpreter check for the name. If it is main, this is going to be your execution point. This is going to be your execution point. How to call the method actually? Because these functions are inside the same module. Same module I can say. That I can call function one. If I run this program, it's going to print. I'll remove these things now. I'm going to comment this thing now. If I comment this thing, what the lexical analyzer will do, compiler, it will skip the comment part.
If that's it.
It will comment the, it will split into various tokens and then skip the comment section as well. Now, this is how you want to call the function. If the function is in the same module, main module, you can call so you can call directly function underscore one. Now, okay. If I want to call the 2.py file function, how to call? I want to call the 2.py file function 3. I want to call. How to call? First thing, what you have to do, you have to import the module name as 2. Don't say py file actually, it's a module actually. 2. Now, how are we going to call this method? 2 dot function 3. 2 dot function 3. It's printing hello world underscore 1. If you want to call function 4, how to call in my main module? How to call? If I want to call, otherwise I'll split the screen. Then you can able to answer. I can split the screen like this. If I want to call the function 4, it is in 2 module, right?
Dot function 4.
2 dot function 4 you have to call. See, if you are calling like this, what will happen? Because see here, I'm just importing the entire 2 module. This function will take memory. This function will take some memory through memory manager. The entire model is taking the memory. The entire model is taking memory. I'm going to ask only the function 3. I'm going to ask only function 3. But just I'm importing 2, it's going to take the entire memory from the heap. Entire memory means through memory manager is going to assign the memory. Okay, if we want to run some functions or want to use some variables, it will take some memory, right? Like if I give import 2, it's in the 2 module, what are the functions available? It's going to take the entire number. This function will take on memory for running, this function will take memory during runtime, it's going to take all memories. What I'm going to do, i'm going to use I'm going to use from statement. From which model I'm going to import? 2. I'm going to import only one function. What function it is? Function 3. Function 3.
3.
Directly you can call. Don't need to refer like this. Directly you can call function 3. You can see the output here. Hello world of 1. If I need function 4, what you can do? Directly you can change over here. Function 4, and then you can directly call the function as 4. That's the reason everyone using from statement. From which module? Module is 2. I'm going to import only one function. Now the memory is saved actually. For this function 3 only, memory will be allocated. Memory will be allocated. For function 4, memory is allocated. If I using directly import function import 2, if I using directly like this, what will happen? The entire function will take memory. Function 3 and function 4 will take memory. This is not the perfect way actually. You have to use from which module you want to import in your current module, and then import the corresponding functions. Tomorrow we're going to discuss about how to read the how to get the keyboard inputs through Python, and then we're going to see the IO conditions. We're going to see it tomorrow.